What's up, guys? Welcome back to the BlockHash Podcast. Quick message from our sponsors, Pika Crypto and BNFT. Pika is revolutionizing the intersection of NFTs and gaming through their Pika trading card game Elders of Kai. The TCG will be both digital, physical, and Web3 integrated, allowing gamers to play and compete in various formats. Whether you are a newbie or a pro gamer, there is a spot for you in Pika's ecosystem. Learn more about Pika and Elders of Kai on their website and social media pages, and join the Pika community on Telegram to keep up with the latest developments. BNFT is a groundbreaking platform that combines the unstoppable force of blockchain technology and the limitless potential of artificial intelligence to revolutionize personalized learning and earning experiences. Now, BNFT also leverages AI to create immersive educational environments for collaboration and utilizes DeFi to transcend traditional e-learning experiences. Learn more by going to bnft.solutions and their social media channels. All links are in the description below. Enjoy the episode, guys. What's up, guys? Welcome back to another episode of BlockHash Exploring the Blockchain, episode 343. Today, I have Constantin, the core team member for IPv4DAO, here to talk about how they are decentralizing IP addresses in their DAO pool. Constantin, welcome to the show, man. How you doing?
Hey, Brandon. Thanks for having me.
It's a pleasure to have you. We're going to have a good conversation. Excited to learn more about what you guys are doing. This is a really fascinating topic that you explained to me just a few days ago about how you were able to do this with IP addresses. I didn't even think it was really possible. So this will be really cool to talk about. Before we do, tell us more about yourself. What did you do prior? What's your background? What's your story, man?
Well, I have a background in information security. I always wanted to be a hacker, but like the good one. And so I've been working as a cybercrime analyst for protecting different large European banks. I was doing cybercrime investigation and black market research. I've also been involved in Bruce Schneier's project as an information security analyst. And I'm also a co-founder of a VPN company, LeVPN. And the mission of LeVPN is to fight for the internet freedom and against the censorship. And so I was involved in this type of missions, of tasks since 2014. Then Ukrainian government tried to block internet access for the protesters during the Maidan protests. And I was and we provided the free VPN access to all to ensure the freedom of speech during these events. And I was involved in different things like this, but like the eye-opening incident like that was the Russian government tried to block the Telegram messenger in Russia in 2018. And that was something that made me think differently about IP addresses, because like any such incident, any kind of censorship incident in IP address, in internet protocol, is always go down to the same easy and quick solution. Then you ban someone's IP address, because IP address is something that you need to kind of have to being able to interact in the internet, to being able to access the internet. So if someone wants to ban a service, they just ban their IP addresses of their servers. And or if someone wants to ban like a person, he bans his IP address, and he's not able to access a different person's service. So what's like Roskomnadzor and Russian government did is that they like banned Telegram proxy servers, but the thing is that they did it en masse. It's like they banned millions and millions of IP addresses daily. They kind of went full on this and tried to block the Telegram. And the Telegram, for the context, was like the last free speech app, I would say, in Russia. So for me, it was a very important mission, and I've been involved with them to to help protect Telegram, to keep it available in on the Russian territory. And it all ended in 2020 with the complete victory of Telegram. But it made me realize a few things about IP addresses, like how scarce this resource is, and how centralized it is, and how unfairly and unevenly distributed IP addresses are. Because, for example, for the context, we have like 4.3 billion of IP addresses, but we could only use 3.7 billion of them because some of them are reserved for like internal use. And out of this 3.7 billion, the things that left for the new projects, for the new industries such as Web3 is almost nothing, because in 2019 we've depleted all of the IP addresses, so we do not have a new IP addresses. And how it worked before is that you go to the regional internet registry, and we got like 6 regional internet registries for each region, that each created like at a different time, and they all manage this big registry of IP addresses. So like before, in the beginning of the internet, to get yourself an IP address, you'll go to the regional internet registry and you just ask them for that, and they would give you like any amount. For example, like University of California and San Diego got 18 million IP addresses, which is huge. I don't believe they use even the fraction of that. And like US Department of Defense got 300 million IP addresses, which is like 8% of the world supply of IP addresses, and is almost equal to amount of IPs the entire China got. And so I kind of started going down this rabbit hole, discovering different aspects of that, and it didn't look pretty. It looked like we have this like public good that became an asset recently, and that creates some kind of the landlords, because 90% of entire supply of IP addresses was distributed for free. And now like large companies, like hosting companies, cloud companies, they charge for use of IP addresses. So we have like this public resource that is being used, that is being monetized by big companies because they were early. And this is also the reason why US owns 36% of world supply of IP addresses, even though the population of US does not represent 36% of world population, because they were early. They got their IP addresses, then they were available. And so I kind of started discover different things about this entire system, and results were not pretty, as I said, because the limited supply of IP addresses and exhausted IP space, it brought us the rising prices for IP addresses. And like in 2022, the price per one IP address got to $60. And for example, in 2014, it was about $5. And before that, there were no secondary market. And we kind of have this like problem, because we need secondary market. We don't have a place to get new IP addresses. If you are like internet service provider, like Starlink, for example, you cannot get the IP addresses assigned, and you need a lot of them, because everyone relies on IPv4. So this is how I kind of started to think and to research more into this space of IP addresses, and that's what's brought me here today.
That's very interesting. Is it the lack of availability for IP addresses that kind of gives it this value right now, or is it other potential uses for IP addresses?
Well, I would say both, because we have a limited supply and we have increasing demand for that. Because, well, everything is based on IP addresses. Each new innovative technology based on internet protocol. There's no, well, that's the most common way to communicate on Earth. Even like IPFS, which is like interplanetary file system. Behind all that is Internet Protocol version 4 mostly. Well, the IP protocol, and kind of everyone uses that. And the more peers we got on the internet, the more will be the demand for IP addresses. And with the recent rise of large language models and all of the breakthroughs in machine learning, it's pretty obvious, for me at least, that we will have increasing demand for IP addresses, for connectivity, for the use of the internet. So we will see more devices, more services appearing in the internet that will require internet address. And that's not talking about like the last billion of people that we onboard in the internet that will all require connectivity as well. They will all need an IP address to be able to communicate on the internet. So we have this like limited supply and growing demand for addresses, which may be like a best scenario for a catastrophe, because you see like in 2022 the price per IP address got like to $60, and it's and the whole trend was like doubling. The prices were doubling every few years. It kind of changed last year because of this new economical situation, I would call it that way. But if that trend were to continue, if the prices per IP address continue to grow, that would mean a lot of change and a lot of damage to the internet community. Because imagine like paying half of your internet service plan just for IP address, just for being able to use an IP address. And that's not something that could not happen. That's if we have these prices doubling a few times more, and we'll have this type of situation where you just paying because you're using a resource that should have been free, which is like a public good, but somehow it became a highly tradable asset. And this is kind of weird, and we need to we need to do something with it. We need to find more innovative solutions on how to manage that, how to solve this problem.
Yeah, it seems much more plausible with the advent of AI and more technological devices, VR headsets and kits and mixed reality. You know, I imagine that just is going to skyrocket the demand at one point in time or another. So that does make a lot of sense. What about what you guys are doing with IPv4DAO? How are you helping to alleviate or even solve this problem?
Yeah, right. Because there are like so many problems with the internet protocol that we have. There's a lot to work on, but we started with bringing more decentralization to this space, because you see, the most of IP addresses are centrally owned. That being said, they belong to a corporation, because you could not get assignment. You could not even like buy them on the secondary market if you do not have like legal entity. Though there are exceptions for RIPE, I would say. But it's like a pretty complicated and long and obscure process. But the thing is that it's the centralized entities own IP addresses, and that implies centralized properties to these IP addresses. So they are not neutral. They are used to optimize for the purposes of the company that owns them, and most likely it's the profit of the company. So for example, if we go back to this Telegram example, when you kind of go to AWS and tells them, guys, we'll need like 2 million IP addresses because Russian government tries to block us, they will not give you anything, because, well, it doesn't mean profit for them. It means the more risks, and that's the kind of situation. And it's only like only one example. Imagine we will really have a network states in somewhere in the future. Those network states without their own internet address pool, that's gonna be like ridiculous. If they rent their infrastructure and everything will rely on infrastructure, that doesn't gonna work. So this is like the first problem we try to solve. We create the decentralized pool of IP addresses. We created we've spent entire season 0 last year to find the best legal entity to make it possible. Because to own IP addresses, you need a legal entity, and to make it decentralized, you need the decentralized legal entity. And we've been searching through different type of legal vehicles, including based in the United States. There were like this Delaware DAO, not the Delaware, Wyoming DAO, LLCs, etc., etc. So we talked to lawyers, we talked with different projects, and we've ended up with incorporating on Marshall Islands through a non-profit DAO LLC, which is the company that do not have a CEO or like any C-suite executives. It doesn't have shareholders. It doesn't distribute profit. So we kind of solving the principal agent problem with this type of organization. And in our operating agreement, we have this smart contract based on which the governance of the DAO is done. And that's pretty innovative way to do it. And so the global idea is to have a DAO that manages a pool of IP addresses. But that is only the first step for us, because as soon as we finish with that, as soon as we got this decentralized pool managed by decentralized community, a DAO, we will start to tokenize IP subnets, and we'll start to bring more properties to this space, such as immutability. We will make it fast, we will make it efficient, we will make it transparent. Because what's happening now with the regional internet registries, they are decentralized because they are in in different regions and so on, but in fact they are still like centralized entities, and there is not enough transparency with them due to different reasons. But we want to make a system that's going to be trustless, because we will base it on the smart contracts. It's going to be transparent, it's going to be immutable, it's going to be secure, decentralized, and that would allow us to bring new properties to IP addresses. We will try to make them neutral and censorship resistant because of this decentralization. Yeah.
Is there any aspect of this that maybe bumps heads a little bit with any of the agencies that manage IP addresses, like in the US, for example? For context, I did a episode quite a while back with the guy that created ENS, the Ethereum name service. And he was doing the same thing. Obviously, we all know about ENS and the .eth addresses and what you can do with them for querying information, potential websites, payments, and whatnot. He was talking about how they've, in the past, have issues with ICANN, which manages domains in the United States, and selling those .eth addresses, or at least making them available with those not being registered with ICANN. And they had a little bit of back and forth with that. I don't know if they ever resolved that issue or whatnot. Just kind of curious if that same thing kind of exists with IP addresses, and if you've had any kind of headbutting going on with any kind of agency that manages it.
Yeah, same exact thing. ICANN manages the IP addresses as well, not only.
Oh, okay, I didn't know that.
The domains. They kind of like oversee, and the regional internet registries manage them more like directly. And we are dealing right now with the regional internet registries. We haven't had problems with the ARIN, which is the North American internet registry, but now we are struggling a bit with the European internet registry, which is RIPE, because we are a new type of legal entity. This type of entity, I think, was created in 2021 by MiDAO, and I'll take this moment to say thank you to MiDAO and Adam Miller, They are really helpful in what we are doing, and their support is so much appreciated. So they've created this new type of legal entity designated for DAOs in Marshall Islands. And as it was only recently created, I think we were like the first 10 DAOs to incorporate there. It's not yet recognized by some of the organizations such as RIPE, because they have this like procedures, because their like agency was created like decades ago, and they have this thing. Then they need to confirm that. But for the moment, I wouldn't say there is some kind of special approach to us. They just trying to figure out what's going on and how to like handle our legal entity. But I would say we are quite early in our mission, because, well, right now we are registering ourselves as a local internet registry to be able to acquire subnets on the secondary market. And the main like challenge in this step we're gonna be, then we will acquire subnets. Then we will go through the process of acquiring subnets, because regional internet registry needs to validate each transfer of IP addresses, even if it's done like directly between buyer and the seller. But so far so good, I would say.
Interesting. So how does IPv4DAO work in a nutshell? So do you guys go and source out the IP addresses and put them in the DAO, and then, that, gets handled as is, or do you have people contribute their IP addresses, or what's the approach to kind of saturate the DAO with IP addresses?
Well, that's a good question, and we haven't got to this step yet, because we need to first register ourselves as a local internet registry, and then we will pass to this step. But that's a really curious thing to do, because there is no way to do it in decentralized way. And so we already have a seller who is willing to sell us his IP subnets, but we want to make it differently, because we are our mission is to bring more decentralization to this space, and we are building it based on open source approach. And so we want to create this kind of instrument that will allow the transfer of subnets using the smart contracts. Because right now, if you want to buy a subnet, you need to find a seller, you need to find, most likely a broker who will help you with all the nuances of that. You'll need to find an escrow, and then go through the regional internet registry to approve your request, etc., etc. But what we want to create is that we want to make a smart contract-based escrow contract that will allow decentralized transfer of the subnets. And we are building that using the Chainlink's new functions system. It's still in the beta, and we are waiting for it to be released. I've talked with Chainlink. I think it's gonna be somewhere probably September or like August, if everything goes well. But this system, it kind of uses decentralized Oracle network, and it allows you to decentrally confirm if the transfer was successful. And we want to build in this direction, and to provide the community with the tools to better handle IPv4 transfer.
Got it. I also noticed that you guys had a token called root token. How does that kind of play into the DAO, and what's the functionality with it?
Yeah, that's our first token, the root token. We have a limited supply of it. It's 255, which is the smallest amount of subnet of IP addresses you could buy. It's like the smallest subnet, 255 IP addresses, and that token is used to bootstrap our DAO. And so we use these root tokens also to compensate our members, our contributors. For example, after the season 0, when we figured out the legal entity that we want to incorporate in, we distributed 8 tokens to the core team. And at the end of this season, we will distribute 25 tokens to the contributors. And well, our objective for this season is to have this first IPs in our decentralized pool. And
Excellent.
and I would add that we are releasing them step by step, and we have 8 next tokens available for mint at mint.ipv4DAO.io. So if you want to participate in our project, just go to the mint ipv4DAO.io and grab your token.
Nice. I noticed in the name IPv4DAO that you guys highlight IPv4, and I know there's an IPv6. I was curious if you could maybe explain maybe what the difference is between the two, and if there's any difference in focusing on IPv4 versus v6, or if that's a silly question or if that's a good question.
That's a really good
it caught my
question.
curiosity.
Yeah, that's a really good question, and it's kind of like holy war in the internet between like IPv4 and IPv6, because before I start, I would say that what we are building could be applicable to both IPv4 and IPv6. It's just in IPv6 we have this like immediate requirement to have a solution. And with IPv6, I think we will have the same exact issues, but like in a decade or two. So the thing between IPv4 is the first version of the internet protocol, and IPv6 is the second. So it's kind of, we skipped 1, 2, 3, and 5, but that's okay.
Why did we skip 5? IPv5, what happened?
They kind of tried to do some streaming type of thing, but well, it didn't end it well, and they abandoned the technology. But the thing is that IPv6 was created mostly to solve this IP address scarcity issue, and it got much more IP addresses. Like I don't even know the name for the number. It's so big. But the main issue with IPv6 is that it's not interoperable with IPv4. So 2 versions of the protocol could not communicate with each other. They could only do so if they are connected to the same computer, for example. If there is a device that is connected to IP version 6 and IP version 4, then it could transfer the information between the two. Otherwise, it's not possible. And so we have this IPv6 created, I don't remember, like 20 years or 25 years ago. And like internet community was like, yeah, we now need to adopt it. And 11 years ago, it actually, like last week on June 6th, it was 11th anniversary of the world IPv6 launch. It was the global effort to increase the IPv6 adoption, to make more devices on the internet to support IPv6. But like last week, it was 39% adoption of IPv6. Which is, I would say, catastrophic, because the thought experiment I use for the like IPv6 adoption, and so you kind of need, if you want to communicate using only IPv6. So there is a thought experiment I'm using in regards of the IPv6 adoption. Imagine you have a website. Imagine you have like a website selling T-shirts. And you kind of decide, do you want to keep IPv4, or do you want to reject IPv4 and only use IPv6? And you kind of do it every year. And so this year, if you do it, if you like reject all IPv4 requests, like even the proxies, all of the IPv4 users, you will only have 39% of the visitors being able to use your website, to reach your website. It means like if you bought a campaign in Google AdWords or something, and you paid for 100 users, you'll get only 39 of them, which is like the almost doubling the price for user acquisition. And it's most likely a no-go for everyone. You'll just pay for IP address, IPv4 address, you'll just support IPv4. But it's like today. But what happens like in 10 years? Because for the last 11 years, the average adoption, increase in adoption in IPv6 was 3 to 4%. And imagine we do good. We do like 4% every year. And in 10 years, we will have 80% IPv6 adoption. It's like, you think, yeah, it's more than like 51%, so it's probably everyone's going to switch to that. But in fact, I would say no, because you'll still have only 80% of users being able to use your website. And you reject 20%, which is huge. Even like if it goes to 95%, a lot of the services will think twice before disabling IPv4. So we kind of still need to rely on this protocol. We still need to use it. And to use it, we still need IPv4 addresses, which is for the moment the biggest problem with IPv4 protocol. Because imagine it's like it's working okay, but it's expensive because we have a limited supply. And so this is this kind of thing that we are facing with the IPv6 adoption. And like in the community, I've spoken with so many people about this, and everyone agrees that yeah, IPv6 is a good thing. We need to invest in that. We need to increase our adoption of IPv6. We need to do this, but it sounds for most of the companies as a investment in fundamental science. Then you do not have like results of your investment right away. And I got this thought that there's like there's this notion of the wartime and peacetime for everything, like for the companies, for the crypto, etc. And it looks like we are in the wartime right now with all this economical instability, all the war going on, well, all of that world situation. We're more in the wartime. And in the wartime, you prioritize the projects that give you immediate results that help you survive. And for most of the projects, I wouldn't say IPv6 is crucial. And well, that's my hypothesis. But I see that the IPv6 adoption since the July of the last year, it doesn't move a lot. It's like 1%. It should have been like 3 to 4%, but this year we have this slowdown, and well, we'll need to keep a closer look at what's going on in the years to come regarding IPv6 adoption. But it looks like it's slowing down, at least at this time. So yeah, this is my take on that.
Good explanation. Final question before we start wrapping things up. So when IP addresses are in the DAO, when you get to that point when the DAO is saturated enough with these IPv4 addresses, how can they be leased out to people, or how can people inquire to get an IP address from the DAO if they want to use it in the future, whether it's a company, an individual, another entity? What would that process look like eventually?
Mm-hmm. Mm-hmm. That's a really good question, and that's our and our vision of this is that we not only want to become another landlord of IP addresses just to collect the rent, etc. No, we want to bring innovation to this space, and we want to build it differently. And for that, we want to tokenize subnets. So you see, we have this smallest amount of subnets that we could use, which is 255. And different tech projects, well, I wouldn't say it's like a consumer facing, but it's more like B2B facing. But for example, if Starlink wants to acquire our IP addresses, let's take them to use or to acquire IP addresses. We will make the system where each subnet will be represented as an NFT, which means, kind of similar to what ENS domains do with the domain names. And that will allow them to be available on public and open marketplaces, basically on any NFT marketplace, and that will create more transparency in this space. It will create the system that is permissionless, and we will build this protocol to manage this NFT bound, subnet bound NFTs that will track if they are being actively used, because we want IP addresses to be actively used, and we want our system to be efficient, to be an efficient user of IP addresses. We could create a system that will activate this through the smart contracts. We will build the abuse and the reputation management system, probably based on some LLMs, and I'm so excited that we are building this from scratch using AI. It's like the gift from gods, because it makes this project so much leaner, because this is the big part of any IP address management system, and we will make it more public, more open, more trustless, fast and efficient. But as how I see it right now, it will look similar to what ENS domain do in terms of the customer could interact with it. So yeah, this is our vision, and I think there's so many things that could be done with IP space using the modern technology, using blockchain, using smart contracts. We could change so many things. We could make it so much better using that.
Awesome. This has been a really interesting talk, and I've learned so much about, the IP address space. Like, I never really thought much about it. The only time I ever think about an IP address is when I got to connect to a new VPN, and I want to appear in the US, but I'm in Colombia, or vice versa, so I can watch Netflix or do something. This is the only time I ever really think about it, but there's this whole kind of world out there around IP addresses and the importance of it and what's going on that I don't think a lot of people understand. And I really appreciate you taking the time to highlight some of that and, the problems and the solutions that you guys are putting on the table. If people want to learn more about the DAO, what you guys are doing, if they want to keep up with things and root you on, if they want to contribute and be a part of it, where should they go? Should they go to the website? Do you have a community? Do you have other docs?
We are pretty active on the Twitter, so you just go to our Twitter, IPv4DAO. We got a Discord channel, we got a forum, and you could reach out to me directly. I would be happy to hear different views, different takes on this project, on this mission. And for now, we strive to, that's the pretty small space, and it's pretty obscure. And that what we want to do is we want to bring more awareness about that before it's too late. Because as I've said, that could be a big problem to entire internet community if we don't handle that right immediately.
Absolutely. Constantin, thank you so much for taking the time to be on the show today, explaining everything in such great detail the way you did, and really contributing to solving this problem and being a part of the industry. I really appreciate it, man.
Thank you, Brandon. It was a pleasure.